स्टूडेंट्स PCM की डिस्कशन कर रहे हैं हम लोग और हम लोगों ने देखा था कि द मेजर कंपोनेंट ऑफ अ PCM सिस्टम इज द PCM encoder. Students, there are three distinct processes that a PCM encoder performs. The first one is the sampling, second one is quantization, and then we have the encoding. Students, sampling को हमने थोड़ा सा touch किया था when I was trying to explain to you the process of PCM on a high level. We'll go into the next slide and we'll talk about sampling in detail. There are three different sampling methods for PCM. Before we discuss each one of them, you need to understand that the TS, let me write here, TS is our sampled interval or sample period. So TS is basically, in all these examples, TS is basically the interval that we are going to span before we take each of the individual samples. Now students, three different techniques. The first one is the ideal sampling. So students, इसमें देखिएगा कि इस ideal sampling में the pulses from the analog signal are sampled at different intervals. The TS or the sampled interval is TS, and we have got multiple different samples at different amplitudes throughout this analog signal. Students, because it is called ideal, because this is the ideal method or technique of taking samples, and it's very difficult in reality, in real life, to actually employ the hardware which can deploy your ideal sampling. In most of the cases, we have got natural sampling. So in natural sampling, students, we have got a high speed switch which is turned on for a small period of time, and what it does is it actually takes these samples once again at an interval of TS, which is our sampling period or sampling interval. Shape of these samples, as you can see, they still resemble the analog signals. We are just sampling it at multiple intervals with different amplitudes. Students, another common method of sampling is called flat top sampling, or it is also called sample and hold. So once again, this is deployed using a circuit, and it creates flat top samples which are of the similar shape of the analog signal. Students, मैंने आपको पहले भी बताया था कि this sampling process, it's worth noting that this sampling process is also known as pulse amplitude modulation. अब students, हमने कुछ बात की थी about the sampling period की. We represented the sampling period by capital T with a small s, sampling period. Students, from our previous discussions, you know that the inverse of period is frequency, or vice versa. The inverse of frequency is period. So the inverse of sampling period, the inverse of TS is sampling frequency, or FS. How frequently are we going to take these samples? That is defined by the sampling frequency. Students, Nyquist, yeah, I know you have heard the name before. Nyquist gave us a very good estimate, a very good formula to come up with the sampling frequency for an analog signal. Students, Nyquist told us that this sampling frequency should be at least twice the frequency of the signal, the highest frequency of the signal. So your Fs should at least be equal to twice the Fh, where Fh is your highest frequency of your analog signal. Now students, when you are sampling the sine wave, you can actually sample it at different intervals with different frequencies. The ideal is a frequency which is twice the highest frequency, but you can sample it with anything above or beyond or equal to this twice the highest frequency. Students, we'll go to the slide and we'll study what happens when we sample an analog signal with different frequencies. Students, in our first image, you can see that we are sampling at the Nyquist rate. the frequency of sampling is equal to Fs is equal to 2f, where f is the highest frequency of our analog signal. So we are sampling it at twice that f, and students, as you can see, the samples that we get are these. We can see that we are able to reproduce an estimate of the input analog signal by using this sampling frequency, which is twice f. Now, students, let's look at the second case. In the second case, students, we are sampling it with a frequency of Fs is equal to 4f, which is 2 times the Nyquist rate. So in this case, we are sampling it at twice the Nyquist rate. Students, in the third case, we are sampling at a frequency of f, so which is half the Nyquist rate. So this is double the Nyquist rate, and then we have got half the Nyquist rate. Students, as you can see, in this second case, we have received some samples which have got literally no value, redundant samples. We're not going to use them. We can actually do without them, as you can see. So you can actually create this signal even without those samples. So when we do the oversampling, or we double the Nyquist rate of sampling, we come up with samples which are not really required. Students, if we do undersampling, or we go below the Nyquist rate, as you can see, it is not even possible to, we don't have enough samples to recreate the exact signal. Students, the best possible way when we are doing PCM is to follow a sampling rate which is equal to the Nyquist sampling rate, which is Fs should at least be equal to twice the highest frequency.